Hi, welcome to part 12 of the video series about vertical projectile motion. In the previous video, we have learned how to draw velocity versus time graph of an object which is released or thrown downwards from a certain height. In this video, we will learn how to draw velocity versus time graph of an object which is bouncing off the surface. As we need more space for this kind of graphs, we are going to learn how to draw it for the cases where downwards is considered as the positive direction. Afterwards, we will see how to convert the same graph to a case where upwards is chosen as the positive direction. Also, while in some questions we ignore the time of contact, in others we must contemplate it. We will start to plot the graphs without the time of contact, as they are relatively easier to draw. Then, we will learn how to draw them with time of contact as well. Let's imagine a ball hovering at a certain height from the ground level. Its initial velocity is 0. Once released, it will accelerate downwards and its velocity will increase by the time. Eventually, it will hit the ground with a velocity of v, and then it will bounce off the ground with the velocity of the same magnitude, but now its direction is reversed. In just one moment, velocity of the ball changes from positive to negative. We have to understand that if there is no time of contact, this change in the velocity of an object happens instantly. Therefore, we start to draw the rest of the graph starting at the exact time that the initial part has finished. The only difference is that now instead of positive v, the velocity is negative v. Once the object is bounced off the ground, it will start to move upwards. During this motion, its velocity will gradually decrease until the object reaches the maximum height, where its velocity becomes 0. After this point, the object starts to fall down and its velocity increases in positive direction again. Once more, the object will hit the ground with the velocity of v and bounce off the ground with the velocity of minus v and repeat its motion. We can't draw this pattern indefinitely. In the exam papers, it is usually specified how much of this graph is required to plot. What about if there is time of contact between the object and the surface? In that case, we will need to make slight adjustments to our graph. First of all, if there is time of contact, an object will not bounce off the surface instantly. It will take small amount of time delta t to come off the surface. Therefore, each bouncing of the object will start a bit further on the timeline than the time it hits the surface. Another point to consider is that if there is time of contact, the collision is an inelastic one, which results in the loss of kinetic energy. Therefore, after each bouncing, the velocity of the object will become smaller. But it is very important to note that despite all these changes, the slope of the graph will remain constant. As we know, the slope of a velocity versus time graph is equal to acceleration, and during the free fall, acceleration of an object remains constant. It is equal to the gravitational acceleration. Before concluding this video, let's also see how to draw these graphs when we choose upwards as the positive direction. This was the graph where we have chosen downwards as the positive direction and there was no time of contact. When we choose upwards as positive, signs of velocities will change. Positive values will become negative and negative values will become positive. Simply put, we will need to mirror all the lines on the graph around the x-axis. On the screen, we can see the graph we have drawn before for the cases with downwards chosen as positive direction and the ball having time of contact with the surface. The only difference when we choose upwards as positive is the mirroring of the graph against the x-axis. In the last 3 videos, we learned how to draw velocity versus time graph for an object in a projectile motion. In the next video, we are going to learn how to draw position versus time graph. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.